Hello and welcome to the last workshop of this year here at GNL. See it, score it, switch it, standards-based end-to-end media quality monitoring. And a warm welcome to the three presenters here, all happen to be partners of GNL. Let's start with Will Law from Akamai. Hello, Will. And Adrian Rowe from Norsk. Hi, Adrian. And we have Brenton Al from TouchStream. Thank you. Beautiful. So let's start with the presentation. So this is what we are talking about today. Check here. So you will all receive an email as soon as the on-demand version of the workshop is available. So you don't have to ask for that. You can ask any questions you want, but you don't have to ask for that question because it's already answered. So the small agenda for today is I start with a quick motivation. Why are we having this presentation, this webinar, this workshop at all? I will then hand over to Will Law from Akamai. He will talk about the theory behind what we are doing here and the standards that have emerged around this. After that, Adrian Rowe from Norsk/Ideas will talk about how we implement this in encoders and packagers. And then Brenton Al from TouchStream will talk about how this will be monitored from the end of the signal chain. In the end, we will answer questions. So if you have any questions during the workshop, please type them here into the question and answer section in the Zoom webinar. We already have some questions that have been asked before the webinar started, so we will cover them later as well. And we try to answer as many questions as possible, so please don't hesitate to ask them. So quick topics around the motivation. Why are we doing this? So this is about live streaming. Live streaming is unforgiving. If anything goes wrong, you don't have a second chance. So you have to really react quickly and have to make sure that everything works fine. The earlier issues arise in live streaming, the earlier in the signal chain they arise, the more components and customers and viewers are affected downstream. So it has an enormous leverage what happens at the beginning of the signal chain. And the third part is bitrate does not equal quality. Network is okay does not mean that everything looks good. So those are dimensions that are independent from each other, and many times we are using the wrong ones. What ops teams need, actually, and we know that because at GNL, we are often responsible for the whole signal chain, for managing stuff that other people have thought about, and for making sure that everything runs smoothly. You need end-to-end visibility. You need to understand what are the parts of the signal chain, how is everything behaving. You need a definition of what is goodness in the quality of the signal and how good is it what we are currently having, especially if you have redundant signals where you most often only see one published while the others are just waiting to be used just in case. And if something goes wrong, you need to quickly identify what's causing the issue. So you need to be very quick in identifying the root cause of what's happening. So what are we trying to close with the technology that we described today? Currently, the live encoders know a lot about quality because they are encoding. They can compare the signal that they get in and the signal that they generate. But that information is lost in a way, and quality of the actual video content is often needs to be rediscovered later down the signal chain. And this is extra decoding and tooling, which is generating costs and time and effort and can go wrong. So we try to use that information that usually gets lost. And if you don't have that information, often decisions about switching or decisions about quality ratings are based on metrics that are available, like how good is the internet connectivity between the packager and the encoder, or how good is the ping latency that we have. But that does not necessarily tell you something about the quality of the actual signal. So you take available metrics, but not actually the ideal metrics that you need to just to make a decision about the quality of different sources that you have at your hand. So what we are trying to explain today is something we named See It, Score It, Switch It, which means that see it, you look at the encoder already knows a lot about quality. This information gets lost. We don't want to get it lost. We don't want to carry it downstream so that others can work on that. Score it means we take this information, we use standardized names, and we'll talk about these standardizing a lot, standardized name for the different quality dimensions that we have, and that we can then attach numeric values to, so that we have a very strict and flexible way in which we can use that information downstream. And then downstream, we can audit it so that we can track the quality that we have generated or named or scored early on. Or at some point, we can also use it to actually do a switching based on this standardized quality metrics. So that's the three parts that we want to talk about. And we will see different contributions here from the three gentlemen who are joining me. So I hand over to Will now, who will cover the theory and the standards behind that. So let me quickly provide him with access to the actual slides. So now, Will, you should have slide control. Thank you.
I do. Thank you very much, Alexander, and good day, everyone. My name is Will from Akamai, and I want to start right as Alexander just suggested, that we constantly use bitrate as a proxy for the visual quality when we distribute OTT content. So I have examples of 3 embedded videos on the right. They all look pretty similar visually, but in fact, one of them is 4 times the bitrate of the other. So clearly, just going on bitrate doesn't really give us what the quality perceived by the end user. What does? Well, it depends on the codec, the frame rate, encoding constraints, HDR, FDR, how far you're sitting from the screen. There's a whole bunch of other metrics that we can actually use to objectively measure quality. And we can measure visual quality by standards, right? PSNR, SSIM, and VMAF is the more recent and a very popular full reference metric. Now, full reference metrics require a copy of the original content, right? So if we look at a distribution work chain, here we have camera top left and an OTT workflow right out to the player on the right. The components in this that have visibility into reference, visual quality reference, or what we're calling MQA media quality, because it can apply for both visual quality and audio quality, are the encoders, right? The contribution encoders and also the cloud transcoder that may be upstream of them, or sorry, downstream of them. However, as this content moves through the network, we lose that visibility, and instead we substitute it with our proxy bitrate, which, as we've just seen and as Alexandra alluded to, often conveys false information about what is actually received. So the goal of the project is to propagate those reference metrics through the standards shown in red here, so that we don't have to rely on the bitrate and that we can get more explicit information about the quality that's being transmitted at each step. So the use cases are primary, right? So again, if you're a cloud encoder or packager and you've got 2 contribution sources that maybe give you media at the same bitrate, but one of them is getting rain fade and the other isn't, one will have a higher quality score than the other. So you can use this MQA data to switch intelligently between the source that's giving you the higher visual quality, even though it's at the same bitrate in each case. Secondly, at a packager, you can do quality-based switching data and add it to manifests. So I want to be clear that this project is not about enabling quality-based switching at the player. It's an audit trail at the player. But if you wanted to add quality-based data to a manifest at the packager level, the packager has to know what that quality is. And this is a standard mechanism for getting it to that packager. Thirdly, at an origin shield, moving further downstream, if you have 2 cloud origins that are offering you a segment, you would, and again at the same bitrate, you would like to choose the one with the higher quality. MQA allows you to do that. At the player, we can track for an individual session what quality the end user saw, especially across ad breaks. So this is an audit functionality. If the end user is paid for HD content, are they receiving HD content? And are the ads that you're inserting that are coming from third parties, do they match the perceived visual quality of the content that they're embedded in? And then lastly, as an analytics provider, can you track the quality of the end users, both for debugging and also for quality assurance purposes, rather than just track the bitrate that the player downloaded? So these are the primary use cases. So the project from our side was initiated back in October 23. Dr. Ushi Pal at Akamai submitted a patent around video quality analysis as a service for OTT, which just got issued last month, which is fantastic. But at the start of the year, Akamai took that project to the SVTA QoE working group and pitched a media quality assessment project. The group adopted it. A lot of people have worked on it since then, and we plan to release it very shortly, if this month, if not January or February. So it is a technical publication of the SVTA. And inside it, we are at one of the steps you see to transmit data. We're leveraging an existing CTA web standard called CMSD, Common Media Server Data. Right? This is a response header that is sent from a server to a client. And we define a custom key name, org.svta.mqa, that carries a list of parameters. And one of the parameters is V, which is the value. So it's carrying both the type of the metric along with that metric score. And then we have various other parameters to correct for temporal resolution or scan order differences, which might affect how an analytics system interprets that score. And the reference, we maintain a table of the more popular and common references, VMAF, PSNR, SSIM. There's a gap, I can't fit all of them onto the slide here. We got some from IMAX. And we've also got the 3 that have been standardized by AWS Elemental and are currently available in production on their origins. We have also importantly defined a generic metric. So this is showing some of the CMSD examples. It's very simple. You've got a score and you've got a value. If you see the score repeated 3 times, as we do for PSNR in the 3rd example, it means we have one segment that's got 3 GOPs, and we're giving you the score for each of the GOPs that are contained within that segment. The orange highlights are our generic MQA video scores. Because let's imagine that you have a system and it's not using VMAP, but you have another measure of quality that you would like to propagate and allow upstream or downstream packages to make selections on. So we just define a generic MQA video metric, has a value from 0 to 100, where bigger numbers are better. And you can design it any way you like. And we provide a mechanism for carriage and transmission of that score downstream. And down at the bottom in the green, it just shows you how this CMSD data fits in with all the other CMSD data that might be sent by the origin or by intermediate CDN nodes. We can also embed the data inside SEI frames. User data unregistered SEI message type, payload type equals 5. We defined a custom UUID. And then we essentially use the CMSD encoding, but we supply an additional prefix to tell you whether it's data that's relating to the frame or data that's relating to the previous GOP, the current GOP, or at the end of the GOP. So it's also simple to understand, and I have some examples over on the right-hand side. For Dash Live ingest, this is where content is segments are being pushed at an origin. So we can't use CMSD for this data because we're doing a post, but we can use CMCD. And luckily, the syntax between CMCD and CMSD is very similar. So in fact, the CMCD simply reuses the CMSD syntax. And there's further examples down there. Nothing changes between the two, and our key name is the same. And this is also how a player might report it to an analytics service. It can receive it on CMSD, and it can send it to analytics, especially with CMCD v2 in the event mode, using the syntax shown here. And my last slide is, you might say, how can we handle low latency? For example, in a low latent 4-second media segment, the origin will start producing the start of the segment, and the player will start consuming it and decoding it before the end of the segment is reached. So if you want to present an average quality score for that segment, and we're sending it in a response header, which is arriving before the first byte of the data, how can it possibly know that information? The answer is it can't. So to solve that, we invented a scheme where the data for segment N can actually be communicated in segment N+1. It's called a temporal reference or temporal offset. So basically, when you receive segment N+1, it'll carry the data for the prior segment. So again, we're not making real-time player switching on this, but we can then develop an accurate picture of the quality that the player actually received. And with that, I return it back to Alexander. Thank you.
Great, thank you, Will. Yeah, so we've seen now that the standard supports a lot of different metrics and a lot of ways in which you can communicate them downstream. In a real life situation, you have to decide for a specific selection of that because you have a specific set of tools that you work with. And I'd like to hand over to Adrian Rowe from Norsk to tell us about how he integrates that into the ideas set of tools in the Norsk universe. So, Adrian, you now have the control of these sites.
Thank you very much, Grand. So yes, I'm Adrian Rowe from Norsk, and yeah, over the next couple of minutes, we'll talk about how it is we've put together the demonstration that ultimately Brenton will be showing to us a little bit later. So Norsk, one of our products is Norsk Studio, all about how you can really quickly build even complex kind of broadcast net workflows in a short amount of time. And this hopefully will act as a decent example of exactly going about that. And then I need to use that button. Okay, so there are two aspects here that I think are both come into play. And for live in particular, as Alexander said at the beginning, you've got some greater challenges. And it's how good you are on a bad day that really matters. And I think for quite some time now, there's been a good story around high availability in a live context of doing things twice, and you'll have some encoders in one region and encoders in another region, and mechanisms for allow you to switch between those, based on availability. What CMSDMQA brings to the table is a similar conversation about how you do that based on quality as well as availability. So the picture at the top, I promise I hadn't seen Will's when I drew it, not least because I drew it initially 12 years ago. And I sort of tweaked it a little bit to match the style that Will had in his slides. So one minor build, so this slide in contrast is about 11 years old, which is actually our recommendation by and large is, unless you have a very specific reason to, don't solve the same problem twice. Don't assume that because you can do everything twice at every single point in the chain, doing everything twice at every single point in the chain is actually going to be helpful. It certainly adds to the complexity, and actually have a hard think about whether it's adding to your ability to deliver a better end user for your experience for your end users. And so actually what we're about to demonstrate is what we would typically recommend people start with unless they really want talk to us about why you might want to make different decisions. But here we're going to set up an environment where we have one source coming in that's going to get processed in two different encoders in different regions, and then we're going to augment that with information that's then going to be used by an origin shield downstream of us that's going to make sure that we have both high availability and high quality. So one of the sort of starting points here is some of this information, frankly, it's only the encoder that knows the answers to, not least because they're full reference frame. In order to calculate a PSNR or a VMAF score, I need the original and I need the encoded content. So there's certain metrics that, frankly, it's only possible to calculate at the center. And so the approach that CMSDMQA takes is to tag each frame as you encode it with some metadata. You aggregate that at the packager, and then that process on its own gives me some big wins, because at that point suddenly I don't need to put expensive infrastructure into place for answers I already know. If I want to know what the VMAF score of a frame is or something like that, I can just go and ask the segment that it came with. It also gets rid of certain complications, because what we're doing is we're tagging metadata to it, to the media. We don't actually care once we've created that metric if we then further down the line start to encrypt it. So if I've got DRM keys, etc. in play, I can make real-time quality-based decisions based on the quality of the media without actually having to be able to decode the media myself, which means that for large-scale deployments, suddenly I don't need to distribute DRM keys outside of a place I might otherwise, I might normally be confident with. And as has been mentioned a couple of times, you can kind of use the CMCD to again pull these stats back up to get real-time information about what user experience is. Are they actually seeing the HD version? Are they seeing this? Are they seeing the version with rain fade? So conceptually, this is what's going on. We've got an encoder that's grabbing, we've got a signal downstream over on the left there. We're encoding that in two different regions. And at a frame level, we're tagging each of those with various quality metrics. The packager then takes those frame-based messages and aggregates them into per segment quality scores. The origin then takes those per segment quality scores, provides them to the switching origin shield, and that switching origin shield can, on a segment by segment basis, make decisions about, is it okay for me to, should I be pulling from region 1 or should I be pulling from region 2 in order to deliver that downstream? And yeah, we've already seen something that Will talked about a little bit, where we're starting off with per frame data. The encoder has per frame information that, in this particular example that we're going to show you, is using SEI metadata, SEI messages in the H.264 streams to tag every single frame with its quality. You can do similar things with ERTMP and so on, to which is adopted by a whole bunch of people as well, so that you can get that granular information. And then in this particular case, as we segment it, we're moving over to sort of header-based, HTTP header-based scores aggregated over the segment. Probably the wrong forum to go into that, but think carefully about what the average of video score, frame score, frame score, frame score, frame score, frame score really means. Because maybe the quality of your segment is the quality of the worst frame in it. Some things are inherently logarithmic in nature, and so you taking an average of each of the scores is not just a linear average of those. So there's some devil in the detail there, but probably not something we need to dwell on. And what comes out of this straight away is, if you do this in the real world, you very quickly start to realize that fidelity is not the same as quality. And so one of the real world use cases that we see all the time with our customers is something like satellite contribution into two different regions, and one of them suffers from rain fade. And what you observe with that is that you get pixelated content where you've had the rain fade as part of your transmission. If you simply look at the VMAF scores and the PSNR scores of that content, it's counterintuitive, but actually you get higher scores because pixelated content has less information in it. I've got the same amount of bandwidth to encode that less information, and so I get a higher fidelity score. So I think perhaps there's a sort of slight vocabulary tweak needed. With PSNR, VMAF, SSIM, etc., are actually fidelity scores and not necessarily quality scores. It's how close is what comes out of my encoder, how close does that correlate to what went into my encoder. At which point, in order to deliver this in the real world, we use what we call filters to add other metadata into the chain. So in this particular example, we're looking at the transport stream data coming into us. Do we have any sequence number errors when we're actually decoding that information as it comes in? Do we get any drop frames? Do we get any issues from the encoder decoder saying it had to invent some data for us, or duplicate data, whatever else it might be? For something like audio, you can do the same. Am I clipping? Am I silent? Am I, what's my dynamic range? Video, do I have too much contrast? Do I have not enough contrast? Do I have black? Do I have green? Do I have pixelation? Those are all things that you can augment your data stream with. And again, what's great with CMSD is I can tag that on a frame basis. I can then aggregate that on a segment basis as well, which means you end up in this sort of world here, where at the encoder, I've got some transport level scores, I've got some decode level scores, I've then got some encode level scores that I'm going to aggregate in my packager and pass downstream, and so on and so forth. And you end up in a bit of an ugly world where suddenly I've got 53 metrics that I need to understand in order to make some of these quality-based decisioning processes. And that's why it's a very simple thing, but an incredibly important thing that's as part of the spec, which is that the spec itself mandates an overall quality score. You've got MQA audio and you have MQA video. It also mandates that those are two numbers between 0 and 100, and that bigger is better. And it also mandates that at an aggregation level, linear is just fine. So at that point, I can have a packager from a different vendor from the encoder. And if they see MQA scores in there at a frame level, they know exactly how to produce overall quality scores. They know exactly how to do quality-based decisioning on a frame basis. That's not to say you can't keep all of that data. So if we look at an example over on the right here, we've given an MQA video score of 54. The PSNR score was actually quite good at 47. The SSIM score was actually fantastic at 100. But we've got some transport stream errors that are actually resulting in us having a lower overall MQA video score as a result of that. So you get both a well-defined, standardized decision metric, and you get the granular detail behind it too. So final couple of points. One is we've created an ability to switch based on content. You have to be really careful when you're doing that, because actually, if I have slight macro blocking for a couple of seconds and I switch away, and in the process of switching away from one encoder to another, I repeat the last couple of seconds, the impact on perceived quality, the suspension of disbelief that's experienced by your end users is going to be much worse, because suddenly they've noticed that 2 seconds have been repeated, and it really takes you out of yourself. Same if you skip. And so a really, really important aspect of an overall solution that's using quality-based switching is consistent segmentation. Consistent segmentation basically says, I need a single source of truth, which is right at the origin, right at the mixing desk over here, or even at the cameras, that says, this is my stream time. At which point, I want my encoders in region 1 to be able to make decisions about where they start new iframes. I need my packager to be able to make decisions about when it starts a new segment, and have those two decision streams be absolutely identical, even without my A stream and my B stream talking to each other. Again, one of the strong suggestions we would make in a high availability scenario is the less your region 1 talks to region 2, the more likely you are to survive unexpected outages and so on. So very quick demo here of what that looks like in Studio. So here we've got something that's mimicking the on-site, where we're injecting some SEI timecodes. We're then making that available over SRT. We then have kind of region 1 encoder that's going to acquire that signal, encode it and package it. We then have a region 2 encoder that's going to do exactly the same, acquire it, encode it and package it. So I'm starting the world here, but you'll notice that neither encoder, I've deliberately disabled both encoders from starting their workflow. So we're going to enable encoder 1. It's going to come up. You should see one connection now at my origin that's producing it, and we're generating some video out the back of that. I'm now at a completely arbitrary point later in time going to enable encoder 2, but because we have those SEI timecodes, because we're using consistent segmentation, you'll see that my two outputs are completely in sync. Now, actually, the fact that they're visually completely in sync was slightly coincidental there. And in fact, I think they were about a frame or two out. So what I've done here is I let that run for about 24 hours. I pulled a couple of GOPs, and then you just saw me scrolling through the images from encoder 1 and encoder 2, frame 1, frame 2, frame 3, 24 hours later. And you'll see there that we transitioned from one shot to the next at exactly the same frame. And that's kind of the ground rule for how I can then do the kind of stuff that hopefully Brenton's about to show us, where we can then make quality-based decisioning on top of that. So thank you very much. Over to you again, Alexander.
Yeah, thank you very much, Adrian. And the beauty of this here is that it's based on open standards. So what we are happy to show is that how different vendors can integrate that and how easily it is being done. So Brenton, I'm now handing over to you the controls of the presentation here. I remove it from Will and Adrian, so I forgot Will, so you could have messed up with the sliding. So Brenton, you now have control. Yeah, great.
Okay, thank you. Yeah, good to be in control and have them out of control. Okay, thanks very much. That's great stuff. So now we're on to the monitoring piece. Obviously, all that's great, but you need to monitor it. So the first thing you think about when you think about monitoring is what are your data sources? So monitoring is about data. What is the data you need? Where do you get it from? Now, you've seen in that it's really the CMSD static header that contains all the information. I'm not going to retell that story, but on the right hand side there, I'm just using the Chrome dev tools, and you can see I've got all the headers there. But really, the one we want to pull out is CMSD static, because that's the one with the data that we care about in this context. Actually, we in our product we actually reformatted into nice human readable stuff, so you don't have to think too much about it. So the second part is once you know what the data is, it's like what are you going to do about capturing it, and where do you capture it? Now, for this environment, we need to, I've simplified the workflow and stolen. Thank you very much, Adrian, for your workflow. But the places you've got to pick this up, you've got to pick it up, from the packager, both packages in the A and B chain, from the media quality origin, media quality aware origin, and then finally from the CDN. So capturing it in multiple places. And what we do is we capture it, we publish it in our own visualization. But you can do this in any tool that you like, any log analytics style tool. Then here's the presentation. So we present this in a workflow style. I mean, you can present it whatever way makes sense to you, but basically packager A, packager B, what are the metrics for that? And we've pulled out the actual, the video quality score, PSNR, structural symmetry, and errors. These are the things we consider the most important. So we visualize those very simply. We also make it possible to view over time. So if you need to go back in time, you can look at it from a visual perspective, which is always very important because things happen at the time, but then maybe a little bit of time passes and you need to go back and see what was actually happening at that time. So making it available in a visual thing is very good. Also, the actual metrics. So here's where we're looking at the quality score, PSNR, structural symmetry, and errors. And basically, you can see in this example, you'll see it more in the demo, that basically when the black line is the actual overall score, and when the errors go up, the score goes down. So this is the problem areas. Of course, when you're in monitoring, so it's great. We've got to know what the data is. We've got to capture it and present it. But of course, you need to alert on it. When there's a problem, you need to see or find out that there is a problem so you can do something about it. And so obviously, we've done a visual thing, change the color from not green. And in this case, one packager, so the A chain is got a problem. We also create simple alerts, again, with a similar bit of information. We make these very HTML friendly so you can view them on anything. But, you can see here that, okay, only packager A has got a problem. So the Akamai, the CDN, and the origin doesn't have a problem. So obviously we've compensated for that issue. So this is like, oh, this is a redundancy issue. It's not the viewer is over. So it's very important to be able to give an alert that gives you the right sort of information to help you understand what is your next step as an operation. Remember, this is live streaming, so you have to act very quickly. And so this is how we did the demo. We simplified it just a tiny bit. We took away the additional origins just to make it easier to set up. So we've got two encoders, A and B. We've got this media quality aware origin that is basically using that MQA video score as its decision to which one to use. So basically, if they're both equal, it will use A, and if B is better than A, it will use B, and that's how you get this consistent thing. Right now, I don't know if I can make that bigger. Can I? Yeah. Okay. So here you are. So this is it running. We've got the two on the left, encoder A and encoder B. which are totally in sync. And on the right is the end user, just a few, just a few hundred milliseconds behind because it's the CDN. In the middle, we've got our quality aware origin that's making a selection. And you can just see the very simple segment log, which is all it's pulling out there is the media quality score. And so basically based on that, they're equal. And so we've selected the primary. We burnt in primary and secondary into the two different videos so that you could tell which one it was using. So all's happy. Now I've introduced some packet loss here, which would be equivalent to a rain fade. And you can actually now see encoder A, the scores are low and you can actually see the visual impairments. It's actually gone terrible. But the end user is now switched to secondary automatically, just because we're judging every time we get a fragment, we're judging the score. And if the score's bad on one and good on the other, we've selected that automatically. So it's happily showing us the secondary, and as you can see, the primary, and that's, by the way, that's 2% packet loss. So it doesn't take much to give a significant impact. And as I said, that would be very equivalent to a rain fade. Now, what's important, is actually now the monitoring. How do we, visualize this monitoring part of it? So we'll just go over to the monitoring, and you can see the packager A as a problem, and we'll just take a quick look into that. We've got a header detection there, so we've failed a header check, which is basically the header check is looking at the MQA video V value, and if it's less than 50, it's signaling that's bad. So we want to know about that. So that 40 there has triggered the error. As I showed, we sort of neaten it up in our interface, so it makes it easier to read. And so that 40, that was the thing that triggered the red. So you know at the package level from that score, okay, we've got an alert. I'll just go back a little bit just so you can see what it's like. Yeah, see that's video scores 65, which is we say that's good. Again, you set whatever threshold makes sense to you, but that's what we've done. Now we're also tracking the actual metrics, like we're extracting the data out of those metrics. So we want to plot those metrics, and the metrics we pull out are the video score, the PSNR, structural symmetry, and errors. In this case, we had 16 errors in that segment. Now, what we also want to do is be able to, it's convenient to look at that over time to see when that actually started to occur. So we've done a very simple history. You can see I did a couple of experiments before we got into recording this session. Now, here's the problem area. Now, I'm actually just going to switch off a couple of the metrics just so it's a bit more clear. As we explained in this scenario, PSNR and structural symmetry, stay flat. But here you can very clearly see the score dropped below 60 or, down to 42 when the errors went up to 14. So it's really clear. We can track it. We can see exactly what time it happened. We can see if it's repeated. All sorts of things. Like you might get little bits, I don't know if anyone's had enough experience with satellite, rain phase sort of drift in and out. And so you can start to see, how is that impacting? So it's really, really, useful to be able to capture this data really simply, and be able to present it in such a way that makes sense to your operation. So now they know what's going on. Now I've taken away the errors, and it's starting to come good. The video, like the packager A, is now coming good. We'll go back to our videos, and you can see that the scores are back up in the 60s, 70s, and they're equal. You'll see that the end user video is still on the secondary, and we did that intentionally because if we decided that we didn't want it to switch straight back, because if it fluctuates a bit, you don't want it just switching back and forward all the time. So we wait, I think, 5 segments before we switch back, and now it has switched back. So we're back on the primary because basically the primary is good, and we prefer to default to the primary. So that's kind of how it works. That's the simple but very beneficial way that you can monitor this. Now I can't go to the next slide. Can you just pop it out of full screen, Alexander?
I will try. Yeah. Okay.
Yeah. Okay. There we are. That's it. And so I hope you found that interesting. Thanks very much to all the people that contributed to that demo. Adrian and his team, and Pedro from my team did a lot of work on making that. So I hope it was impactful and showed you the simplicity of the value of CMSD MQA.
Yeah, thank you a lot, Brandon. Before we come to the Q&A, I have two questions for the about the presentation. And the first was when you talked about that you introduced packet loss. I
Yes.
think we have to clarify where that packet loss is incurred, because it could be after the encoder and before the packager, so that the packager could also see that. But that's not the case. You introduced it before the encoder. No, that's the crucial part. No.
Correct. Yeah, we put it between. We basically tried to simulate what we see in the real world. And something like rain fade, you'll have a perfectly good signal at the sports stadium that goes up over satellite. Maybe the one stream goes up over satellite, the other goes out over fiber. That's a very common use case that we'll see. You get some rain fade in the satellite, and so what we've done there is we introduced packet loss between the origin encoder that it was putting in the SEI timecodes and all of that kind of good stuff, and the region 1 and region 2 encoder packages. Those particular encoder packages were deployed actually on the same machine. That's kind of how we typically do it. Obviously, we do have setups where those are on separate machines. At that point, you tend to be in QoS-based networks. And so I think seeing major loss between those two is more unusual, but not impossible.
Mm. Okay, thank you. And the second question is that the actual switching was taking place within the packager, the origin server, not the packager, the origin server. You had
Correct.
a specific, and that was not a product of TouchStream or not a product of Norsk. It was a custom-made packet-made origin that was just made to demonstrate what we are showing here, just to make sure what we saw. That was a custom solution. No? Okay.
Yeah. It wasn't very difficult to build, but you can. I mean, certainly CloudFront already does support it, although you need to use the CloudFront media package for it to work. But someone like Fastly could easily, build that. It's not very difficult.
I suspect one thing that we'll be adding sort of sooner rather than later would be a serverless switcher deployment that because again, it's not especially difficult, challenging logic to do the switcher. It's not utterly trivial. It's not 5 minutes work, but neither is it 5 months work. And so that's something I suspect will add to the whole Norsk capability and make sure it's easy to deploy in a serverless environment. So again, you've got high availability and low cost and so on associated with it.
Yeah, and it's relatively easy because it's working on metadata. It's not having to decode anything. That's the beauty of it. No? Okay.
Correct.
Great. Okay, with that, I'd like to come to the questions that we received before the webinar already started. So thanks a lot for everybody who contributed these questions. I really appreciate that. So the first question is, how much latency is there while the algorithm selects the best start bit rate? And the second is, what does prefetching mean for the player? Is it supposed to reduce latency? And again, these questions have been asked before the webinar. So perhaps, Will, would you like to answer these questions?
Yeah, so on question number 1, right? So as I made clear, we are not talking about quality-based switching at the player. It's not doing ABR based on quality here. So there's no algorithm selecting the best starting bitrate. That's not part of this project. In terms of latency, though, we do compensate for that by that temporal reference parameter that's attached to the metric score when it's communicated by CMSD. For question number 2, again, prefetching, not part of this initiative at all. CMSD can do prefetching, but that's a property of CMSD, and we're just using CMSD as a data transfer standard and using it to transmit media quality assessment data.
Okay, thank you. Okay, the next question. Would like to better understand how far upstream for live content signals can be monitored, analyzed, and switched, and what the limitations are in terms of ingest protocols and underlying video codecs? And I'm just reading it because I know for myself that I often hear to these webinars as a podcast. So I'm just repeating it although everybody can read the question here. So, Adrian, would you like to cover that?
Sure. And that's from a standards perspective. There aren't limitations. CMSD, I can attach arbitrary data per frame or per GOP or per segment. At which point, that's why we sort of started with the standard reference metrics, your VMAF and your SSIM and your PSNR, et cetera, et cetera. And I know that this is true of other vendors who play in this space. Actually making real quality assessments, you need to look, that information is useful, but you need to look more widely than that. And that's why we've taken a kind of filter approach where you can drop in a filter that says, actually, let's tag some metadata associated with transport stream continuity caps. Let's add some metadata associated with the decoder step. You always draw pictures of, here's an encoder. Well, the first thing that happens before an encode, unless you've got 2110 or SDI or something coming in, is a decode. And actually, you often see the issues in the decode of what's coming in as much as that. And then what's nice here is that we can then do things like, what's your color space? Is this really HDR when it's supposed to be? Am I getting content that's too loud? Am I getting content that's too quiet, and so on? So ultimately, it's down. This is going to be where you're in a kind of per vendor world. We have a process where it's very straightforward for us to put in standard metrics and/or custom metrics. If you want to particularly go, I'd like to switch based on which of my streams has got more blue in it or something, then you could absolutely do that. I think one thing that is worth mentioning, and I should have said in my initial pass through, is that the MQA video and the MQA audio scores are going to be, how those get made up from all the constituent parts is going to be down to your encoder and/or your encoder vendor in particular. The packager, it should be transparent to them because there are rules about how you aggregate, etc. But how I come to an overall quality score as an encoding vendor is going to be down to that encoding vendor, and somebody else will do it a different way. Mm-hmm. But all standards based. That's and all interoperable as was demonstrated with between us and TouchStream. That was all just based on what the spec said we should be doing.
Great, thank you, Evan. Let me look at that. Keen to know more on MQAS on Akamai's Fairplay MPEG Live linear streams. So it says Akamai, so it has to go to Will.
Maybe I should get off mute. So Declare, what we presented is actually payload agnostic, right? We're transmitting data with CMSD headers. We're not embedding it, aside from the SEI, which is inside the video codec. We don't know if this is coming from Akamai. We don't know if it's got Fairplay. We don't know if it's MPEG-Live. It'll work across all CDNs. It'll work across all DRM and common encryption schemes, as long as they're transmitting adaptive segmented-based media is, I guess, one of the requirements here. So to be clear, this is not Akamai specific. It's not tied to Dash, and you can use it with both VOD and live streams from any vendor that you like.
Okay, cool. Thank you. So the next one is, which standard set of data are defined to be requested by CDN supplier in RFP? That's a great question that I would like to cover because RFP is my first name. So yes, I'd love to see an RFP that goes into details so much that it mentions MQA and these quality metrics here. I've not seen that before, but I can only encourage to more specifically define what kind of quality you expect. I can only answer that in a general way for tenders because I don't see a way where you would request a certain MQA setting. I can imagine that you say, okay, MQA support both on the encoder side or on some downstream component is a beneficial characteristic of your service. So currently, I wouldn't require it as a mandatory requirement because there are not that many vendors that have already implemented it. It's standard-based, so that will change, but currently it's not there. But it's definitely something that you want to know about and that you can attach a weight to in answering the quality of the certain RFP quote that you hand in. But on top of that, I can only encourage to include more specifics about quality that you define or that you want to see. For instance, we often see CDN tenders where it says that the quality has to be high all the time. So you have to define what is high. And we've seen some tenders where this is defined in a very granular way, which is fine. Then you can argue about it. You have something that you can measure. It's something that you can objectively prove. But having just something like high quality is not helpful here. So looking into what you really need, what you really want to do, and define that in objective terms that you can already measure is helpful. And again, MQA is something that you could look out for currently, but not necessarily as a mandatory requirement. What do we have here? So what can be done to compare pre and post encoder broadcast quality according to globally established standards like, as I just said, excellent, very good, good, and poor. So Edwin, why don't you take that one?
I think the kind of as you said, Alexander, that it's definitions of standards around that, exactly what's meant by excellent, what's meant by very good, what's meant by poor, and so on. And I think one of the strengths of CMSD and CMSD MQA in particular is it doesn't mandate any of that. What we can do is we can tag arbitrary metadata to a stream and have that metadata follow the stream, beginning with the on-site encoder, the contribution encoder, and ending at the player, and then getting it back again with CMCD. So you have complete visibility of all of those metrics. In terms of exactly what those metrics are, well, there's a whole bunch of industry standards. So VMAF, PSNR, SSIM, etc. Similar on things like loudness. If you want to make sure that you are when you go to an ad break or something like that, you're not breaking noise limits and so on and so forth. Maybe talk to the whoever's doing the server-side ad manipulation to inject adverts, to tag each of those segments with loudness scores and so on, so that you can mandate and verify that no, actually we were within legislative boundaries, etc., etc. So the good news is the standard doesn't care. The bad news is actually some kind of standard definitions of those terms would be really useful, exactly as you said when you were talking about RFPs.
RFPs, yeah. Okay, yeah, got it. Brandon, I think the next question would be for you. How can post-encoder video quality be compared to the quality viewed by the end user on the client? So we have encoder, after that the quality, what is displayed in the client, how can we measure that?
Yeah, well, okay, so the super simplistic answer to this is nothing changes, post packager. Like it is whatever the quality is there, that's the quality that's going to get to the player. You could sort of interpret a little bit more into that question. It's like, well, which part of the bit rate ladder? And these quality scores can be associated with every bit rate. So you can have, typically people have about 5 video things, and so you can add a quality score to each bit rate, and you could measure that. There's multiple ways to do it. You could, CDN logs and whatever. But it's much more. If the question is around that, that's more a log analytics type of answer. But in reality, nothing really changes from the packager onward. You're just passing the bits forward, moving the bits with name for a company.
I think there are some opportunities there as well, especially in a kind of screening of streaming context as well, because one of the things that we've observed is that, especially if you're using your codecs like AV1, occasionally, if you've got relatively simple content, the quality difference between your 8K 8 megabit stream and your 1 megabit stream, or even your half megabit stream is negligible, in which case why send them all? And I think this kind of quality assessment and monitoring and routing actually then gives you opportunities to say and maybe save your CDN bill a little bit by going, I tell you what, I'm actually going to push the lower bitrate one here, because why do I need both this and this in my rung when there's no perceivable quality issue between those? So, but yeah, that's the kind of stuff we're doing in the lab. It's not something that's in production anywhere, as far as I know.
There's another answer as well that sort of Will touched on in the early part of it, was like when you're stitching ads in, do you want to know that the quality is consistent? Now, to do that, you're really going to need to enhance the CMCD part of things, so you can actually grab it at the player and publish it back. But there's a few additional things. Like there's more that could be done. We're at the beginning here. And I think it's sort of opening up some really exciting opportunities to do things that we couldn't really do before.
Yeah, yeah, thank you. And our answer was longer than the question, so that's good. Thank you very much for that. Okay, so that's it for the questions that had been prepared. But now let me check if everything works, because I already added the other ones that have been asked afterwards. So I continue with the slideshow, and we are now going over to the questions that had been asked during the webinar, and we try to cover as much as possible now. So the next question is, are there any other, I assume, encoders than from Ideas, on-prem encoders present supporting CMSD MQA? So of course, we have Ideas now that supports this. I think, Brandon, you have worked with encoding solutions that support this. So perhaps you can
Yeah.
share what you did there.
Yeah, well, yeah, AWS Elemental supports it, but it's Media Live Media Package. I can't really remember. Like, you need to be using Media Package v2. I can't remember if it's if it's supported with the Elemental Live on-prem encoders. It's certainly supported with the cloud encoders. Yeah, so
Yeah,
the only ones I know are AWS, and whether that's on-prem, I can't be 100% sure.
yeah. Will, have you seen anything in SVTA about that?
No, and just to be so the audience get the right idea here, the spec is still not complete or published, right? We plan to publish it. So asking have people implemented it, I think Ideas are right at the front of this and one of the first adopters. The CMSD metrics AWS are putting out are not using the SVTA recommended key, but hopefully they will once we publish the doc. So I think this is a good question to ask, but ask it 6 months to 12 months after the spec's been published, and then we can try to judge the adoption rate.
I would add, ask your encoding vendor when they are going to support it.
Yeah.
Not if. Say when.
Yeah. And you can put that in RFPs as well. Okay, good. The next question, are there any proxies packages known that can enrich encoder quality metrics if encoder cannot enrich it? So that's practically, it's now turning it up around. So we said, hey, you can do all the quality analytics after the encoder, but that makes you need to decode, to DRM, decrypt, to have machinery in place. That's what we are trying to avoid in a way here. So of course, there are things that can do that. So perhaps, I don't know, Adrian, do you know of tools that could do this afterwards? Which is trying, we would try to help you get rid of that.
Short answer is I don't. Being both an encoder and a packager provider, obviously the kinds of things a packager could do as well as packaging would be, DRM keys aside, if it had access to them, etc., would be to decode. At which point you could add the kinds of metrics that I put down as filters. Am I seeing low contrast levels or overly high contrast levels or silence on one and not on another, and so on. So yes, you could. You obviously can't do the full frame comparison type stuff there because you don't have the original to compare it to. But absolutely, a packager could, in theory, take an arbitrary stream and make quality-based assessments around it that it then tagged, for all the reasons that you might do in terms of intelligent routing and quality gathering. Both sides, there's benefits all around on that.
Yeah, I've got to say, we did some experiments with this, but we were kind of like teeing off from the same source and using FFmpeg with filters, in Lambda function. We tried all sorts of super, experiments. We always ended up extremely late. So you're at least half a dozen fragments late with the score. So it's definitely possible, but it's never going to get the same value as what you've just seen. You're not going to be able to switch at the speed. Like we were switching then on the exact fragment, the first fragment we saw with a problem. You're never going to be able to do that if you're doing it post packager.
Okay. Thank you. Yeah,
it's hardly expensive.
Yeah, it is, and that's what we're trying to avoid here, because there is a place where this is already known. So why not take that? Now, that's the whole idea. So we are now at the hour. We will take a couple of more minutes because we have only a few questions left. So if you want to stay and listen to the questions, fine. If you want to leave, also fine. You can look up the recording later on. So the next question that we have is, I could see live tracking of VMAF and touchscreen dashboard. Is that possible to check VMAF of VOD content at large, let's say 100 contents? So that seems like a UI question. So you have VMAF tracking in touchscreen dashboard, and how would you use that information to visually display 100 pieces of VOD content?
Yeah.
Is that a use case for you, Brenton?
I almost suspect the person who might have asked this question. Yes, that has been asked of us. We are working on how to do that. The whole thing is slightly different because, a VOD, not everyone's playing VOD at the same time, so the whole scenario is different. But we are actually working on a VOD scanning technology that uses scoring, and scores the VOD looking for problem areas. We'll get.
You will eventually get there. Okay.
What's this space? Yeah.
Okay, cool. Number 11, can you please mention again which vendors support CMSD today? So this is a generic question. So CMSD is used in many use cases, not only here in the quality space. So perhaps, Will, you have an overview of that?
Yeah, I know some, I don't know all. So AWS Elemental supported at the origin level, unified streaming supported at the origin, Ideas supported, TouchStream supported. A CMSD is just a constructed header. So at Akamai, you can construct CMSD headers. We don't add them automatically. I would think all the major CDNs have a metadata type edge scripting where you can add CMSD data. I don't know on the packaging vendors specifically who add CMSD origin headers by default. It's an open standard, and we don't track, no one licenses it or anything, so it's hard to know exactly who's using it.
Okay, and it's not phoning home, so you don't count all the users.
No.
Okay.
And by all means, ask your origin and your packager if they do support it.
Okay. And the last question, number 12, like the 12 days of Christmas. I imagine that trending reports of the past performance could then be used for ops to plan for discovered periods of problems, such as spring and fall sun outage times. So trending reports, I just have to read it again, just of the past performance could then, so discovered periods of problems such as spring and fall sun outage times.
I think that makes sense to me, and I think Brenton's probably the person to answer it. But
okay, go ahead.
I'll describe what I think the question is saying, and then feel free to disagree. Which is, another way perhaps of phrasing it is: should I look at the weather forecast before choosing how I capture my live signal? And the short answer to that is yes, you should. If you are using satellite in particular, if you know that you're downlinking it somewhere that's going to have an enormous storm, especially if maybe your satellite signal's low on the horizon, then yes, the chances you're much more likely to have issues like rain fade in those circumstances than others. We've been lucky enough to have some fantastic aurora borealis over the last year or two because of sunstorms and so on. And again, those can interrupt particular signals. Now, what we would typically suggest is if you get to roll the dice twice, roll two different dice. So let's use satellite for this particular signal, which is great because I can downlink that. Implicit multicast, I can download that in all sorts of locations, so it's fabulous in those kinds of terms. But if I can do satellite and fiber, happier still. The satellite's unlikely to get upset if somebody accidentally digs just down the road from me. At the same time, the fiber's unlikely to get upset if it rains really heavily. So
fiber first satellite backup is our standard setup right now for the event streaming business. That's what it's mostly booked. Yeah. So Brenton, would you like to add to that?
Well, just on that satellite bit, the other thing is if you're doing dual satellite, have satellite vendors where the satellites are in different directions, so your dishes are pointing in different directions.
Yep.
That will actually, you'd be surprised how much that mitigates rain, what the potential issues of rain fade. But perhaps back more to the actual question here is, I think that makes a lot of sense because it would be, if you were tracking what's happened in the past along with the weather, if it's a weather related thing that you're protecting against. So it would be good. You could definitely try to get a better feel for how big an impact certain types of weather have by tracking this data. and seeing if it really is an impact. So I think that's a really valuable thing to do. But then of course you've got to look at the weather. You know, we all trust the weather report, don't we? Because it's never right. But you know, how you use that data in future things is, you know, that's obviously going to be, you know, have a certain element of risk to it. But it does make a lot of sense. Trying to figure out what the impact of certain conditions are on your quality would be a very useful thing to do. And obviously you collect it.
And this sounds like a follow-up workshop that we do with hydraulics for storing data for a very, very long
There
time
you
and then
go.
integrating it. And so I see the next one popping up already. So thanks for
Yeah.
the
Yeah.
overlap here. Yeah, so that brings us to the last slide of the session here. So if you want to reach out to us, please do so. We're happy to answer any questions. We covered all the questions asked here, so I'm glad to see that. Thank you very much. Thanks to all the listeners who kept through here to the end and see that recording later on. And thank you very much for the three speakers here and for everybody in the back end who prepared these demos. I think that's really helpful and really good to see everything. So yeah, from the bottom of my heart, thank you to all of you and have a great festive season and the holidays and Christmas and however you call it and whatever you do over the holidays. Thank you very much. And
Thank you.
Take
cheers
care.
and goodbye.
Thank you very much.